We are going to take a look at today at operations with rational expressions. And so rational expression, just really meaning that you have this fractional expression, and we're going to deal with simplifying them. So one thing that we do have to consider is just how to simplify common factors. So here you see A over C times B over C. That common factor of C can cancel out to just A over B. So usually what we have to do, because they're not quite as simple as what we're seeing here, so we factor the numerator and denominator if we can, and then divide out common factors, which are basically sets of parentheses that match. One thing that I do want to make sure that you're clear on is that we can do this and simplify when it's multiplication, but if I had A plus C over B plus C, this is really one whole quantity and one whole quantity. So in this case, I cannot simplify those C's, only when they're attached with multiplication. Okay, so here are some examples, and as you can see, they're a little more complicated than what we just saw. You always want to start by factoring. Factor the top, factor the bottom, see what's in common. So in this first one, label that number 1, in the numerator, you have a common factor of x, which if I factor it out will leave me with an x plus 7. In the denominator, I have an x squared. And if it helps, you can think of that as x times x. Well, now I have an x in the numerator and the denominator that I can simplify, and this will simplify to x plus 7 over x. Again, I can't simplify those x's because this x up top is really the whole quantity x plus 7. Here's another example that factors on the top and factors on the bottom. So in the numerator, we're going to factor into 2 sets of parentheses. So x times x for the x squared. 3 times 5 to give us 15, and we need a negative 5 and a positive 3 so that we get that negative 2x in the middle. In the denominator, that's a difference of 2 squares pattern. So that factors into x plus 3, x minus 3. This common factor of x plus 3 is the same in the numerator and denominator, so we can cancel it. And then we're just left with x minus 5 over x minus 3. When you multiply rational expressions, it's straight across the top and straight across the bottom. There is no common denominator needed to multiply rational expressions. So here is an example where we don't see any addition or subtraction. You're just going to go straight across the top and straight across the bottom. Or you can think of this as one giant fraction, and then you can simplify before you multiply. So like I could say, okay, I can take a 5 from both the numerator and denominator. I can take a 2 from both the numerator and the denominator. It's up to you how you want to go about it. I'm just going to go across the top, across the bottom, and then simplify, but it really does not make a difference. So when I go across the numerator, 5 times 6 is going to give us 30. X squared times x will give us an x cubed, and then we have that y cubed. In the denominator, 2 times 10 will give us 20. X doesn't have anything to combine with, but y squared times y will give us a y cubed. So now when I go to simplify, I can take a factor of 10 from the numerator and the denominator. My y to the thirds are going to cancel, so I really have that 3 over 2 from the 30 over 20. And I'm left with x cubed over x. Well, this x cubed is really x times x times x. So I can take an x from both places. X times x is x squared. So we've got 3x squared over 2. Division, we rewrite as multiplication. And it's multiplication by the reciprocal. So you keep that first fraction the same and then write it as times, flip the second equation. So here, this is really over 1. So I can go ahead and rewrite this as 6x squared plus x minus 15 over 4x squared times 1 over 3x squared or plus 5x. I now do need to factor each of these components if I can. So here, the x squared plus x minus 15, I'm going to factor that, let's see, maybe a 3x and a 2x and maybe a 5 and a 3. That'll give me 9 and 10. So if I have a positive 9 and a negative 10, that'll add to give me the 1 in the middle. And that's over 4x squared. times, I'm running out of space here, 1 up top. On the bottom, you just have a GCF of x, and then you're going to be left with 3x plus 5. So now this is one giant fraction. When I multiply, I have a common factor of 3x plus 5 on both the top and the bottom, but that's the only common factor. So in the numerator, I'm left with 2x minus 3. In the denominator, 4x squared times x is a 4x to the third. You may have to add and subtract with unlike denominators, and that gets a little tricky because you do have to have a common denominator when you're adding and subtracting. So you'll have to multiply by a form of 1 to get a common denominator. Once you've done that, you'll add or subtract and then simplify if you can. So here's an example, and if you can, it would help to rewrite anything that could factor in factored form because it'll help you see what you need to multiply by. So here I have a common factor of 3x, which will leave me with x plus 1. So I can get up to a 9x squared in this denominator if I multiply by 3x over 3x. So now I'm going to have a 9x squared on the right, I have a 9x squared on the left, but I need an x plus 1 over here. So I'm going to do x plus 1, x plus 1. So on this left-hand side, I have 7 times x plus 1 over 9x squared times x plus 1. Over here, I have a 3x squared over 9x squared times x plus 1. Now my denominators are the same. So I have 9x squared times x plus 1 in the denominator. And then up top, I can distribute. So I can say I have this 3x squared plus 7x plus 7. And then if I could factor this polynomial, I would to see if I could simplify it all, but 3x squared plus 7x plus 7 is not going to factor. You also may see addition and subtraction of polynomials. This is really just combining like terms. So when you combine like terms, just remember like your fourth powers are going to go together. So 1x to the fourth and a 3x to the fourth. It's going to be a 4x to the fourth. There's no x cubed, no x squared, so we can move down to the x's. 8x and 2x is 10x. And then our constant terms, so -6 and -8 is going to be minus 14. Over here, it's the same. You have this plus in between. You will not distribute if you have a plus or minus in between parentheses. So 2r to the third and 2r to the third is just a 4r to the third. We then have a 4r squared and 5r squared, so that'll be a 9r squared. And a 2 and a -3, that'll be a minus 1. Here's some subtraction. The only thing I would recommend with subtraction is writing it as addition of the opposite so that you don't forget to carry that sign through. So you've got a -4a to the third and a -3a to the third. That'll be -7a to the third. No a squareds. Then you've got a 3a and a -3a. So those will cancel. And then a 3 and a -8. So that'll be a -5. Same thing here, I would recommend is adding the opposite just so you don't forget that negative sign. And then you combine. So we start with the -6x to the fourth. You have a -7x to the third, 7x squared and -2x squared. That'll be a plus 5x squared. There are no x terms. And then we have a +8 and a +2. So it'll be a plus 10. When you multiply polynomials, if any parentheses are raised to a power, do that first. So what I mean by that is if you have x plus 4 to the second power, that is not x squared plus 16. You have to write that as x plus 4 times x plus 4. Then you distribute and combine any like terms. Forgot my parenthesis there. Okay, so your assignment for tonight is the operations with rational expressions and operations with polynomials on Khan Academy.